3, we're going to look at congruent triangles and looking at congruent parts and proving triangles congruent. So in this first problem, or in this first example here, it says definition of congruent polygons. Two polygons are congruent if and only if their corresponding parts are congruent. So corresponding means they're matching parts. And so we've got corresponding angles, angles that match up. In our picture on the right, we're just looking for congruence markers. So the angles that are congruent would be B and J because they have one angle marker. So I would say angle B is congruent to angle J. I would have angle A is congruent to angle H. And angle C is congruent to angle K. And then the same thing I would look for corresponding sides. So sides that correspond also have the same congruence markers. And so for the sides, I have segment AB has one congruence marker. And so the corresponding one would be segment HJ. And I chose to put HJ because A has two congruence markers, and it's the first letter I listed, and H has two congruent markers, and it's the first letter I listed. So that's how I base it on, is the congruence markers of the angles. And then I have segment BC is congruent to segment JK, and segment AC is congruent to segment HK. Okay, so those are our congruence parts. So corresponding angles, and then we had corresponding sides, and my congruent statement then would say which triangle is congruent to which triangle based on matching parts. So if you go back up here and you look at the angles, I'm going to take the same order that my congruence of the angles went in. So for triangle ABC, I have triangle BAC is congruent to triangle, and then the matching parts that went with that in the correct order would be JHK, because B is congruent to J, A is congruent to H, and C is congruent to K. So that's my congruence statement. All right, in example 1, it says show that the polygons are congruent by identifying all the congruent corresponding parts, then write a congruent statement. I'm going to do problem B just because it doesn't have as many matching parts, and it looks a little bit different than the example we did above because it has the angle measures on it. So I would start by putting my congruence markers in based on matching parts here. So I can see that angle L and Q are the same measures, so those would be congruent. So as far as the angles, I have angle L is congruent to angle Q. And let's see, I have angle J is 52 and angle P is 52. So angle J is congruent to angle P, and K is 78 and M is 78. So angle K is congruent to angle M. Then I'm going to go through and I'm going to do the matching sides. So for the sides, I have side L or JL is congruent to PQ. So JL is congruent to PQ. And again, I ordered J, then L, and since J and P are congruent angles, I put P first, just like I put J first. Then I have 39 degrees, or 39 side, so that has a measure of 39. I'm going to put JK for the 39 side, and J has 2 congruence markers, and P has 2 congruence markers, so I'm going to put that up first, and PM. And then the last one is 40, and 40 here. So I have LK, and it is congruent to QM. L and Q are congruent, so I put L and Q, both of those first. And then I want to write a congruence statement. So I want to say the first triangle is congruent to the second triangle. So I'm going to say triangle LJK is congruent to triangle QPM. And there's my congruent statement. Okay, so things that can help us out and figure out parts that are congruent. So this is something that we'll use in a lot of proofs, and it's called corresponding parts of congruent triangles are congruent. We don't have to say that every time. We usually just say CPCTC. Corresponding parts of congruent triangles are congruent. Basically, it says if 2 triangles are congruent, then their corresponding parts are congruent. So if we know that 2 triangles are congruent, then we know each of the parts that match would also have to be congruent. In example 2, it says in the diagram, triangle ABC is congruent to triangle DFE. Find the value of X and Y. So I want to figure out what parts match. I have triangle ABC is congruent to triangle DFE. This actually tells me what parts go together. So I see that A and D are in the first location. So that means that angle A is congruent to angle D. So A and D are congruent, which means that angle D, if A is 45, angle D has to be 45 degrees. B and F are in the second location. So that means that those guys are corresponding parts. So angle B would be congruent to angle F. So B is 99 and F is congruent to that. So that means that F also has to be 99 degrees. And then C is in the third place and E is in the third place. So angle C has to be congruent to angle E. C is 36, so E is also 36 degrees. Okay, so we did learn some things. We wanted to find out what X is, and I do have that angle F is equal to 8y minus 5, but it's also equal to 99 because it was congruent to B. So I can make an equation to solve for y that says 8y minus 5 equals 99. And then I'm going to solve for 8y. So I'm going to add 5, which would give me 104. And then when I divide by 8, I'm going to get 23. So I find out that y is 23. Then I need to do something for x. Well, I need to find where x is. X is one of the sides, and it says x, it has, well, the side that has x in it says 2y plus x. And it looks like that corresponds to the side that has angles at each end of 99 and 36. So that would be 38.4. So those are equal to each other. So I'm going to write an equation for that. That 2y plus x equals 38.4. Now I already have y, so I'm going to substitute that in and say 2 times 23 plus x equals 38.4. 2 times 23 is 46. And when we subtract 46, it's going to be a negative, but that's okay because it's not actually a length of a side, it's just the measure of x. And we should get negative 7.6. Okay, next theorem. This is called the third angle theorem. And basically all it says is if I have two triangles and I already have two corresponding and congruent angles, then the third one, even though it doesn't say, the third angles that's left have to be congruent to each other. Okay, so I've got C and K are corresponding and congruent, and B and J are corresponding and congruent. So even though it didn't show me anything, I know that A and L automatically are. In example 3, what I'm wanting to do is I'm wanting to find X and Y. And so actually this one right here with the hand is 5X minus Y. So I need to figure out what it corresponds to. I'm going to give these some letters real quick. I'm going to call this A and B and C, and let's make this D, E, and F. So based on the congruence markers, I see that angle A and D would be congruent to each other, and B and E would be congruent to each other. So by the third angle theorem, C, which is 18, would have to be equal to F, which is 5X minus Y. So I'm going to write that equation. 5X minus Y equals 18. And then I also know that angle D, which has the equation 3X plus Y, is going to be equal to angle A. Well, I'm going to have to do some math to figure out what angle A is. I know that triangle ABC has to add up to 180, and A would have to be, ABC would have to add up to 180, and B and C, we already know those, so we should be able to find angle A. Measure of angle A plus 148 plus 18 equals 180. 148 plus 18 is 166. And when I subtract 166, it says the measure of angle A is equal to 14. So that's this guy right here. That's 14 degrees. So the two purple ones have to equal each other, which is 3X plus Y equals 14. All right, this is going to take you back to some algebra and when you did system of equations, because I have two unknowns and two equations. So our options are to do elimination or substitution, and I am going to do elimination, which is where you add or subtract the equations to get rid of one of the variables, at least temporarily. So I'm going to add these two equations together because I see that I have a negative y and a positive y, and if I add those, they will be eliminated. So I'm going to add each of the columns. So 5x and 3x is 5x plus 3x is 8x. Negative y plus y is 0, so it's eliminated. And 18 plus 14 is 32. And then I can divide by 8 to solve for x. So x is 4. Once I get one of the numbers, then I can substitute it back into either of the original equations and solve for y. And I'm going to put it in the bottom one there. It says 3x plus y equals 14. I'm going to substitute x in, so I have 3 times 4 plus y equals 14. That's 12 plus y equals 14. Subtract 12, we get y equals 2. I'm not going to do 20, but it's the same concept there. You may have to find a missing angle. You will have to find some extra parts. We know that these two are congruent, so they would equal 52. This is 52 and 90, so we should be able to figure out what this would have to equal so that our triangle would add up to 180, and then you would have a system of equations to solve. Okay, we've got one last thing here, and that is a 2-column proof. So we start that with our statements and our reasons. We always start with the given. So what do we know here? And I'm pretty sure it's marked correctly, but we have that segment DE is congruent to GE, segment DF is congruent to GF, angle D is congruent to G, and angle DFE is congruent to GFE. So those are all my givens. I'm going to write them all down. And it's very sloppy because this thing is hard to write with. Okay, so those are all of our givens. What I want to show is that the triangles are congruent. So in order to show that my triangles are congruent, I need to know that all of the corresponding parts are congruent. So I have, in my 2 triangles, I know that I have 2 pairs of corresponding parts that are congruent, or 2 pairs of corresponding angles that are congruent. So by the third angle theorem, I know that the third angles are congruent. So angle DEF would be congruent to angle GEF. And that's the third angle theorem, because if I know that 2 pairs of corresponding angles are congruent in a triangle, the third one has to be. So now I have congruent parts there. And I just need a third one. And I'd like to show that the third sides, there are EF on both of them. Well, how do I know that those third sides are congruent to each other? So this takes us back a little bit. But EF is congruent to itself, EF, and that's the reflexive property. Now I know that all of my corresponding parts are congruent. And so this is, so I know that the triangles are congruent. And that's because all of the corresponding parts are congruent. And that's the definition of congruent triangles. Okay, you guys also have an assignment for that one. Page 258, numbers 1 through 8, all. And I will see you on Monday.